Hi, in this video we will discuss alkanes and their formulas and how we can predict the formulas of alkanes. First, what is an alkane? Well, as you can see on the screen, any compound that contains only carbon and hydrogen and whose molecules contain only single bonds, that is no double or triple bonds, so just carbons, hydrogens, all single bonds. Here are some examples of alkanes. You will notice that they all have just carbons and hydrogens. They all have single bonds and no oxygens, no hydrogens, anything like that. You'll also notice that a couple of them have rings, that is carbons that form chains that bend around onto themselves and form a cyclic compound. These are called cyclic alkanes or cycloalkanes. Which ones of these are cyclic alkanes? Those two. Notice that in the first case, there's a ring of 6 carbon atoms. Each carbon still has 4 bonds, so there are 2 hydrogens attached. And in the second one, there's a ring of 5 carbon atoms, and it happens to have 1 other carbon atom attached to it. Now, you should pause the video at this point and try drawing more examples of alkanes. Go crazy with it, using as many carbon atoms or as few carbon atoms as you want. Obviously, the smallest number of carbon atoms you can use is 1, and there's already an alkane on the screen with 1 carbon atom, but try 2, 3, or higher ones, make chains, make branches, make rings, whatever you want to do, and you will find that these are all alkanes. Some of them might be cycloalkanes if there are rings. Okay, now let's draw some alkanes systematically so we can figure out about their formulas. We'll start with 1 carbon atom. How many bonds does it have to have? Obviously the answer is 4. And so therefore, how many hydrogens do there have to be? Again, the answer is 4. Okay, let's move on. Or let's talk about the formula. CH4 for 1 carbon alkane has to have 4 hydrogens. By the way, this compound is called methane, and it's a real compound. It is the stuff that comes out of natural gas jets, or at least primarily the stuff that comes out of there when you light your Bunsen burners. It's also used to heat your home if you use natural gas. But it's a real compound. Now, the question is, can we draw it any other possible ways? Well, here's a possibility. Is that a different compound? Well, let's look at the model and notice that there's really only one way you can have a carbon and 4 hydrogens. So whether you draw it the first way or the second way or this way, drawing it more realistically in a tetrahedral format, it's still the same compound. So really just 1 compound, formula CH4. Let's move on to 2 carbons. Okay, how many bonds would there have to be if you have 2 carbons, which clearly have to be attached to each other? 6 bonds, clearly 6 hydrogens. So the formula would be C2H6. Again, there is a real compound of formula C2H6. It's been found to have certain properties, and it has been called ethane. Again, a real compound. Always, when there's 2 carbons, it turns out there's always 6 hydrogens, which fits the theory very well. Are there any other ways of drawing C2H6? Well, let's look at a model. Notice that there's really only one way you can have a C2H6 molecule, although you can rotate around that bond, but that does not make a new compound. It's still just ethane, still has the same properties. What if we draw it that way? Still the same compound. What if we draw it that way? Still the same compound. So in spite of the different ways you can draw it, it's still the same compound. It's called ethane, and it still has the formula C2H6. Let's move on. What if we have 3 carbons? How many bonds do we have to have total so that each carbon has 4 bonds? The answer is 8. 3 on one carbon, 3 on the other, and 2 on the carbon in the middle, so that each carbon has 4 bonds. And then, of course, 8 hydrogens as well. And so we predict that a 3 carbon alkane would always have 8 hydrogens, so it'll be C3H8. Again, I've made a model for you. Notice that it's not really straight across as suggested in the structure that I drew. It's bent. And notice that each of those bonds can rotate, but it's still the same compound, still the same molecule, has to have the formula C3H8. Again, it's been found to be a real compound. It exists in the world, and it's called propane. You've probably come across propane if you grill steaks on a gas grill in your backyard, or if you heat your home with propane gas, this is the material that you use. It's a real compound with real properties, different from ethane, different from methane. What if we draw it that way? Same compound. What if we draw it that way? Same compound. What if we draw it around a corner? Still the same compound. Doesn't matter how you draw it, it's still C3H8 and it's still propane. Now, looking at the pattern, can you predict the formula of a 4-carbon alkane? Notice 1 carbon, 4 hydrogens, 2 carbons, 6 hydrogens, 3 carbons, 8 hydrogens. What about 4 carbons? Once you predict the formula, draw a structure and see if your prediction was correct. You can do it as we've been showing you so far for the first 3 alkanes. Now, preview for next time, is there more than one way to draw a 4-carbon alkane? I think you will find the answer is yes. If so, what do you predict about compounds that have been discovered of the same formula with 4 carbons and however many hydrogens you work out and their properties? Will each of the different ways you can draw it have the same? That's it for today. See you next time.